So here we'll be completing the other two layers, and then we'll switch into the network design and some attack surfaces we'll be revisiting and see how to mitigate it. So now uh, you know the reason why you need a TCP protocol, because you need to control the traffic, and you need to regulate the traffic depending on several factors such as network congestion and the receiver side buffer constraints. So first things first thing is to make a connection oriented service. You need to know some identifiers on both sides of the entities, which is the TCP sender is a process. Okay, TCP receiver is a process. I hope you know the difference between a process and a host from an operating system perspective. A host is a computer device. There are multiple processes run inside the computer. This is the connection between one process sitting inside the host of a sender device and another process sitting in the host of the receiver device. And what is the connection identifier? How do you identify a connection? Like if you want to identify a packet that belongs to two entities, you know the source address and the destination address predominantly and the payload. Right? In TCP, how do you do that? Are there any special identifiers used in the transport layer? Okay, what is the IP address? IP address tells you which network interface it is associated to the network interface of the computer. But the computer runs multiple applications. You can run a web browser, right? You can run your own application. You can have several applications running on it, right? There are multiple clients running on your machine. How do you communicate the packets to the corresponding application process? Because all packets that enter into your computer comes with the same IP address, right? Because your IP address is same. If it is an email application, if it is a web browsing or a video streaming application, does not matter. Everything sits in your computer. Everything is connected to the same network interface card. All the packets that come inside come with the same IP address. Now you need to differentiate the packet and deliver to the corresponding process. What is that you are going to use? What is the identifier to separate a packet that has entered into the system? You have to deliver the packet. For example, you have a computer. This is your computer, which is host one, which is having a network interface card, which has a MAC address A and which has an IP address A, and there are three processes that are running in the system. This process is some email client. This is some web client that you're using, maybe a browser. This is some video application, video streaming application. You are watching some, uh, let's say, some Amazon video or some Netflix video, some video application. Okay, there are three processes. This is process one, this is process two, and process three. And your computer is connected with one Ethernet cable, which is connected to the rest of the world through in the internet. And all of these applications are consuming packets from some machines in internet. So all packets that enter into the system will have the same IP address, which is IP address A. Right now, I have to see the packet and assign it to the corresponding process. How do I do that? Because IP address doesn't serve the purpose once I enter into the perimeter of my system. IP address serves only at the granularity of the internet. The IP address job is to deliver the packet to one particular host inside my internet. So it has entered my host. The IP job is done, right? But now I have to deliver to the particular process inside my computer. What is the information I require? I think somebody said in the previous session. Sorry. Process ID is different. Process ID is internal for the operating system. Okay, but this is something else because this information goes even outside of the internet. The packet that goes out carries this information with it. So have you heard of port numbers? right? So port numbers has a one-to-one mapping with your process. Okay, let's say this client has a port number, let's say 123, okay, 456 789, some arbitrary numbers. You may have heard of some standard port numbers, something like HTTP uses a standard port number of 80, SMTP has some port number, but I am saying arbitrary number. Is there something wrong? Am I doing some mistake, or like what is your theory here? There are some standard port numbers. For example, your SSH traffic is on some port number 22. SMTP is on, I think, 25, if I'm not wrong, and HTTP traffic is on 80. These are well standard port numbers. You cannot assign to some other protocols. But here I'm saying that each process has some arbitrary port numbers. What are we missing here? The key idea is all these applications are predominantly client server applications. Whatever I'm talking here is a client process, the process that is consuming or getting the service from some server, right? The HTTP server is a server side process that is running. If the process is server, you are serving somebody in the internet, your port number should be known to them, right? So for example, if I want to put a web page on my computer, I want to put a web server, I will run a program, and it is a HTTP web service, right? Then I should host this process on a well-defined port number, which is 80, so that anybody who want to talk to my machine, they know that 80 is HTTP, is a web service. So if it is the process is running on the server side, and it is a standard process, then it will have a dedicated port numbers like 80 for web service, 25 for SMTP, 22 for SSH, and something like that. Because when I want to get service, I should know your port number, right? If I assign a random port number for a service, how will client reach me? For the client to reach, they should know the IP address, which DNS is helpful. But how do I know which process I'm running? They don't know. That is where you have a standard port numbers, right? 80 and things like that. This is for the service server side. For the client side, whichever program that you are running, your operating system assigns an arbitrary number, that is your port number. So this also goes along with the packet. So when the reply comes back from the server, until the IP layer uses the IP address, the packet is delivered, the packet comes inside. If this packet belongs to the email server, it will contain the port number of 123. So your operating system quickly knows which process it should be delivered. The packet is delivered to the corresponding process. It is something like the process ID that you said, but it is not the process ID, it's the port number. Okay. So a TCP connection should able to identify a port number and what else? Now the question is, this port number is not unique, right? Because TCP is, this is one process inside one computer. This is another process inside another computer in the internet. I need to uniquely identify them. So TCP, the flow is basically a tuple, which is the IP address and the port number. Okay. So the identifier that you use in the transport layer is both the IP address and the port number. Okay. So that is the identifier information. Right. So now let us get into the mechanics of how TCP works. To establish a connection in a TCP, you need to first do a handshaking. I hope you might have studied in your networks course. It has a three-way handshaking, right? What is it? What are the three-way handshaking packets exchanged? First, client will send a packet which is called as sync. Syn stands for synchronization. I want to synchronize with you, so it will send a sync. And what server will do is, server will reserve some resources for catering to this connection. This connection, it will reserve some resources, like some allocate some buffer to store the receiving packets, and it will assign some variables necessary to manipulate the TCP connections, assign some sequence numbers and things like that. So it does some bookkeeping. It will allocate some resources for that connection. Okay, and then it will reply. Once that is ready, it will reply with sync act. Okay, which means it is acknowledging the synchronized packet sent by the client, and now the server wants to sync with the client. So that is sync plus act. So it will reserve some resources, and then the final acknowledgement is given for the sync packet sent by the client. This is called as the famous three-way handshaking thing. This is where all the bookkeeping is done, all the resources are reserved on the client side and the memory side, and further the actual data is communicated by the client and the server. Finally, when everything is done, the connection is terminated because the resources that are allocated should be released and reused for some other connections. This is how TCP works. And what could be the attack surface that can happen here? If I want to attack in this mechanics, what I can do? So one popular attack that happen is called a sync attack. Have you heard of this attack? Sync attack happens at the connection establishment phase. As I mentioned, when somebody is sending a sync packet, what a server is doing, the server will reserve some resources, some buffer, assign some variables, initialization like sequence numbers and things like that. Now, if I want the server to be not to be used by anybody in the internet, I am the attacker, and you created a server which runs on TCP. What you typically do is any client who wants to get your service will do the TCP handshaking. Once the connection is established, you send the data packets. The client will be using your service. It could be a video service, email service, or any service over the internet, which runs on IP and TCP. Now, as an attacker, what I can do is I can do denial of service attack, which is typically called as DOS. DOS is denial of service. I will be kind of bombarding your server in such a way that any client who comes will not have any promising connection established. Then they will not visit your server. In this way, I am kind of bypassing all the clients that come to you for the service. I kind of send them away from getting your service. How is that possible? Can you think of a strategy? If you are an attacker, there is a web service that is running TCP. You don't want any clients to use that web service. You want to just bombard that server so that the server should not respond to any benign clients. How do you do it? Is there any strategy that you can do? What is a simple strategy that you can do to attack? Sorry? Video? Yeah. What is that strategy? The DDoS is a distributed denial of service. I'm talking about a very simple denial of service. Distributed denial of services, you are working in a distributed manner to do the DOS thing. I'm saying you are just one attacker device. You want to disrupt the service. What strategy that you could do? Just from this understanding of this TCP that you're seeing here, right? So what did I say? When a client sends a sync packet, it wants to synchronize. Then server will reserve some resources such as buffer, some variable initialization it does. So obviously server's RAM is limited size. Okay, what it means, the server can cater only a limited number of connections. Because let's say I reserve a RAM space for in particular for handling the TCP connections. Let's say I can reserve only 10 buffer units for 10 TCP connections. So what an attacker can do is it can repeatedly send a sync packet. I will send one sync packet, server reserves a resource, then it will reply with a TCP ACK, sync ACK, and the client will not reply to that thing, it will send another sync packet. Then server reserves another set of resources in its RAM, then responds with an acknowledgement. Then I won't again respond to establish the connection, I will create another sync packet. So I keep bombarding the server with sync packet. This is called as sync attack. You get what is a sync attack? I repeatedly send multiple sync packets, and server keeps reserving resources for that. And then finally, server runs out of all the resources. Now, any genuine client that sends a sync packet, server does not have enough resource. So now client cannot establish a connection; it just goes away. Right. So this is how I create a denial of service attack, which is a popular sync attack. So even in layer 4, there are some sort of attack surfaces that can happen. Is that clear? Okay, this is one type of attack that you can do in the TCP. Right. So coming to the last layer, which is the application layer. Okay. So application layer is the highest, uppermost layer, which is the most right. What is it? Uh, the entire internet is constructed only for this layer. This is where content is served and clients are consuming the content. Now here also people can play with a lot of attacks. First thing is like people can have you heard of this thing, something called as defacing a web page. So defacing a web page is a web page default has some content which is genuinely created for user consumption in the internet. So what attackers will do is, so basically a client that is sitting will kind of send a request over HTTP. I hope you remember HTTP protocol. You just send get, you ask for a resource, then the server, if the resource is there, it replies with a 200 OK and sends the resource, and then the resource is in terms of HTML objects. You will receive the image or the text of the web page, then that will be displayed in the browser. That's how you are accessing a website of any web page. So defacing is an attacker, okay, sees how sees any compromising point in that web page and implants attacker's content into the web server, right? So I created a web page like an Amazon web page. If I can able to compromise, I see how the content is stored and how it is managed, and if I see some loophole in that, and if I can kind of intrude into the system, I can go to that folder. Basically, this is a program running in the server. It is a computer, and this is some file that is in the file system of the server. If I know some operating system, okay, first things first, you don't just need to have the networking knowledge alone. You can also exploit through the operating system to get into establish some attacks like this. So if I know how to exploit the operating system vulnerabilities in the server, maybe the server is running an Apache web server on an Ubuntu machine, and that is not properly hardened. That is not properly set up. There are some compromising points or vulnerabilities. I can use that attack to get into the system, access the file system. Instead of this HTML file that is served by the web server, if I can able to access the file system, I can change this to attackers HTML. Here I will put my own content. I plant it inside the file system. Anybody else who is accessing the web server will not see the original HTML, will see the attacker's HTML file, which means I have defaced the page. You might have seen in the news, right? Some web page is defaced. Some attacker will put his own propaganda statement inside in some genuine websites. So this is how people will do it. For that, it is not as easy as you think. You need to know what operating system the server is hosted, what kind of stack that they are using, Apache LAMP stack, or there is a Google web service stack and things like that. You need to know all these things, and then you need to see which version they are using. Is there any compromising point there? Then use that as a loophole to enter into the system. Okay, so this is not completely with the networks. You need to know the operating system internals, the file system layouts, how to gain access of a file system through the application layer and things like that. Okay, so this is one type of attack that can typically happen. The other type of attack that can happen is if you are not properly coding your application layer. Okay. For example, you are creating a web page. So let's say you are creating a web page. This web page has some authentication measures where you enter username and then user password, and you want to authenticate the user. Okay, once you authenticate the user is kind of you verify the identity of the user, you authenticate that user is true by means of proving that the user knows the password, which is supposed to be known only by the user. Okay, so now I'm using something like an lamp stack. Okay, which is an Apache web server which uses a MySQL database for storing all my data and uses a PHP for web page development. So let's say I store all these details in my database, which is a relational database, which is MySQL database. Okay, so I have a table. I maintain a table. That table has 3 columns. So see here, this has nothing to do with the network protocol. You need to know the vulnerabilities of the database management and the SQL statements. This has nothing to do with that one. Okay, so in this SQL, in this table, I have the ID. Okay, I have the username, I have the password. Okay, the way I design is this web page, this fields I will retrieve, and then I generate an SQL query, and the SQL query will look for a particular row in the table that verifies for the particular username and particular password. If that is matching, that will return the ID of that user. If this ID is there, then the user has authenticated, right? If the ID is not there, the user is not authenticated. Okay, so if you are just looking in the principle of working like this alone, an attacker can easily attack the system, and that kind of attack is called as SQL injection. Have you heard of the SQL injection? Right. So this comes from the poor coding of your application, poor coding in the application layer. So what typically people will use is, you initialize a variable which is let's say some -1, and then you get the user information. You put it in the variable. You get the password information which is typed by the user in the web page. You get this, put this in the 2 variables. You create a SQL query. What is the query? Select. You use a select query. You use this user parameters, user and password from the table, and then you display the ID. If the user information is wrong or the password information is wrong, what will be the output of the select? It will be 0. There will not be anything that is returned by the SQL query. If there is a match, the matching ID will be returned by the SQL query. Okay, so what a simple coding that you can do in the JavaScript in the web page side is, you run the select query. If the select query does not reply anything, this ID which is initialized in your page will be -1. So what you do is, if ID is equal to -1, not authenticated, else you authenticate. Which means if ID is something, there is a match. If there is nothing returned by the SQL query, the ID variable which is -1 initialized will be the same, and then you assume that it is not authenticated. How do you do the SQL injection here? Okay, so the way you do the SQL injection is, what is the SQL syntax for this? 1 equals 1. I'm not sure if it is 1 equal or double equal. I think 1 equal 1 is a OR condition where this condition is always true. Okay, so what happens is, select, in the place of username, I will try to type this condition. Okay, and I use double hyphen. What is double hyphen in SQL? is a comment statement. Okay, so what I will do is something not precisely the same syntax. Pardon me, I don't remember the exact syntax. In the user field of my web page, I use some single quotes, okay, and then use this 1 equals 1 and then comment. Now the user variable, instead of typing the username, I did something like this. This is called a SQL injection. So what happens is when it goes to the select query, the user variable in the select query will be replaced by this. Select user comma password and so on and so forth. What happens is in place of user, this empty string will be there, and then 1 equals 1, sorry, or is a logical or. This condition is always true, and this is a comment statement. So what I did is I manipulated my select user comma password from table and so on and so forth. So what happens here is it will be select single comment or 1 equals 1 and then comment statement. So what it means is this query will run only until this, and because of this comment statement, the rest of the query will be treated as a comment of your SQL, and this condition will always be true. Why? Because there is an or condition. Certainly user will not have an empty string, but or I'm using a condition 1, which means either this or this should be true. So this select query will always return some true information. True in the sense it will now select, it will display all the IDs of the entire table, which means what it returns is not an empty string, it returns some non-empty string. But what did you do in your authentication? If nothing is returned, you say not authenticated. If something is returned, you say authenticated. Now something is returned by the SQL query. You go to the else part, you authenticate the user. You see how serious the issue is? I don't even need to know username and password. I just go, I inject some SQL query, and I manipulate your validation logic, and then I bypass the system. I get into you. I'm treated as an authenticated user. I compromise. I can do whatever I want to do. Right. So basically, in application layer, there are several ways of doing it, and the other network layer aspect attack surface that can happen is, okay, this is your client, and your enterprise network can maintain something called as HTTP proxy. Have you heard of this HTTP proxy? What is the purpose of HTTP proxy? If there are many people accessing a web page, which is mostly static, I don't need to every time access the web page from the actual server. I maintain a copy in my HTTP proxy server. Any future person who is accessing the same web page will be delivered the same content from my local proxy rather than accessing the web page, which is really sitting in a faraway one. In that way, I can reduce bandwidth. I can contain the traffic that goes to my internet, and it works in such a way that as long as the web page is content is same, first web page I can access from the real web server, subsequent web page comes from the proxy. And now if this web proxy is untrusted, right, you can also kind of serve with your own web page, or you can do a man in the middle attack and do all sorts of things, right? So that is again another attack surface that can happen in the uh, application layer. Okay, so the whole story here is every layer has its purpose. For functionality, you need to do some sort of broadcasting, flooding, and all these protocols. But from an attacker's point of view, they can exploit. They can use that as a exploitation space and then attack your system. Okay. So now comes the second part: how to handle all these protocols and vulnerabilities in terms of any protocols or strategies are in the design stage. Okay. So any questions? So So some of these slides I have discussed already. I will quickly glance over. Okay. So first thing is when it comes to network security, you should understand the domino effect. Domino effect is a sequence of disks. When you push one, everything will be a chain reaction. So since you have a protocol stack, that will also create a domino effect. You don't need to attack every layer. You attack the lowest layer, the entire communication is compromised. Because what is the lowest layer of attacking? Physical layer is a physical attacking where you can rewire it. That may not happen mostly because the premises are protected with the physical security team. The most lowest layer in the software based attacking is layer 2. When you attack something in the layer 2, everything goes to the layer 2. So entire thing is compromised if nothing is happening in the higher layer. Okay, so that is called as a domino effect, because security is nothing but attacking a system. And what is how good the security is? How do you justify how your weakest link in the entire system is? Any attacker will attack the weakest point in your system. The strength of the chain lies in its weakest link. That's the security principle. Okay, if you superimpose this logic in the protocol layer stack, you attack the lowest layer, you compromise the entire stack. Right? Is that clear? So that is this. So OSI network protocols, which is Open Systems Interconnect, which we discussed in the first session, is stacked in a hierarchical structure. So you attack the the lowest layer, you can compromise the whole thing. That is the domino effect, right? So that's what it is. Now we have discussed the protocol layers and some attack surfaces. Now let's come to the second part of the talk, which is mechanism, security mechanisms. There are several security mechanisms used in network security. I just briefly glance over them so that you get familiarized with. First kind of security mechanism a network infrastructure should ensure is authentication. So what is authentication? So who should use a network service? Why do you want to authenticate? If you are running a banking service, you should authenticate only the bank customers. You cannot let everybody else to see the database. If you are doing Amazon, you will have only people who are Amazon customers who have created a valid login account. They sign in. So authentication is to let people use the network services they are deserved to use. Okay. So how do you do that? How do you authenticate a user? How do you first identify the user? There are many ways to identify the user. One is by who the user is. This is the recent trend of authentication. If any of you have iPhones or Apple devices, your usual authentication is using the Face ID, right? You are who you are. Like if I want to identify you, this is one way, because your fingerprint is a has a one-on-one mapping to you. Your Face ID, your retina pattern, everything is a Face ID. So first thing in authentication is you should first identify who. How do you define who? That is based on what the user is. That is fingerprint, Face ID. That is one way of authenticating who the user is or what the user is. The other way of authentication is what the user possesses. For example, when you are going to an IT company, how do they know that you are working in that IT company? You have an ID card, right? Or if you are working as a network administrator, you are accessing some critical production services, ID card is not sufficient enough. There will be some hardware key that will be given. You need to carry that all the time. Only when you insert that key, you will be authenticated. So you can identify the user not just by who they are, physical feature, or you can also identify by what they possess, your ID card. This is like another layer of authentication. First one is very strong. The second one is you can easily bypass. How? You can give the ID card to someone else and then they can also barge in. But first one you cannot. Okay, so it depends on different levels of security. And what are the other ways? There is one more way to authenticate, to identify who the user is. Sorry, signature. Okay, right. So signature is one way. What the user knows, you know how to do the signature. Nobody else, because you have to do the signature which is unique to you. The other thing is the password. You give the password, you create your own password which you remember, nobody else know that. So that is how you know. So these are the three ways you identify a person by who they are, so that you can authenticate them. Okay. The next type of mechanism is authorization. So what's the difference between authentication and authorization? Authentication is you are verifying you are the right person to use. Authorization is, okay, I have verified you, but what information I should provide you is determined by this authorization. You may be the student in the institute. I will give you very limited access to the internet. You can use only, maybe you will be allowed to use only some IEEE Explore or portal, or you are not allowed to use Facebook or any other social media websites in the institute, let's say. So I can control what you can access based on your role. That is authorization. Authorization is depending on the nature of that person who got authenticated. I will decide what they are supposed to use, what service they can use in that internet or in that network. That is authorization. Okay. This is varies with user and user. Students have different privileges. Faculty will have different privilege, or system administrators will have different privilege, and things like that. And as a security mechanism, the typical recommendation, which is by default followed by many network security experts, is use the principle of least privilege. What do you mean by that? It's a very simple. If a user is allowed to access some resources, that is the privilege that the user has. You should not give, you should not kind of generally do some wild card things. When a user wants to use one particular service, give him access only to that particular access, nothing else. So that's a simple, simple hard and fast rule, principle of least privilege. And the last one is accounting. Accounting is just getting to know what are all the events that has happened in the system throughout its operation or life. Why do you need that? First two is protecting the user, authenticating them and authorizing them. The last one is, even after doing all these things, somehow the system got compromised. Somebody has attacked. So what you need to do, you will do some postmortem analysis, like when the attack has happened, what is the route the attacker has taken. You need to study that. In order to study that, all these related events, somebody logged in, maybe the attack is something like you gave your ID card to your friend, your friend used your ID card, entered. That is a compromise. So how do I get to know later? I should go back and see what are the events that has happened, who which ID card was entered in, and which person has come in. Maybe there is a camera in there. I can watch the camera footage, and this thing, all these things should be reported or recorded, and that is called as accounting. You gather all the data. If some unforeseen event happened later, you go back, do the data analysis, and then find where the anomaly has occurred or where the compromise has happened. Okay. And this is the most important mechanism in the network security or the network design, which people call this as AAA service, AAA server or AAA service, which does the authentication, authorization, and accounting, which is very important for network administrators from a security point of view. This will tell who should use your network, what services they should use, and then have the record of everything to fall back in case of any unforeseen events. So now comes into the very light layer of the cryptography. When the users are, first thing is how to authenticate them, right? So now comes the encryption, where I have authenticated users. One user is authenticated, another user is authenticated. They are good, they are trusted, but the network they use is untrusted, is full of maybe they may have attackers, I don't know. So I want my data to be not eavesdropped. They can see the content, but they cannot they should not interpret what is the actual content. So what typically you do is encrypt. Encrypt is you convert the code. It's called obfuscate. You kind of change the content into something else, and only the person who has the key can apply it and then reverse the content to the original one. It's basically something like let's say you can say A, for every letter A, you use the fifth letter. For every letter B, you use the fifth letter after B. So your key is 5. If both the parties understand that the key is 5, the message is unreadable because wherever A comes, there will be B, C, D, E, right? I use the fifth letter. Wherever B comes, I use the fifth letter. So I have some understanding of translating my original text to some text which is not understood. You call it as a cipher text, which is transmitted. If this cryptographic mechanism is very strong, an eavesdropper cannot able to decode the text just like that. So cryptography relies on this premise that you come up with a function where without knowing the key, it is impossible, either impossible to decode or it is computationally not tractable. Okay, which means it takes exponentially different attempts to decode the packet, but the time they take to decode it is not sufficient to decode the packet because it takes years or maybe hundreds of years to decode it. At that time, this message may not be useful at all, right? So that is where quantum cryptography or quantum techniques are coming in, which tries to kind of decode the packet with very less number of attempts, because the technology of quantum computing helps you to convert an exponential problem into a polynomial time problem. So that is also another attack mechanisms people are doing, and that is another dimension of quantum cryptography. Okay, so let's not go into that, it is not beyond the scope. So one common use that you might be seeing in many of the cryptographic based secure communication is public private key. Let me not again go into the detail of the cryptography. To understand in a very layman terms, how many of you have traveled in an airplane with a luggage? Have you heard of this TSA lock? What is a TSA lock? Yeah, TSA lock is like a push lock. You will be given with a key, right? And then you just push the lock, right? And then you can alone open the lock, but actually TSA lock means the key will be with the security authorities as well. Nobody else can open the lock, only the TSA security agencies can unlock it. Okay, the simple term is there is a push lock. What is a push lock? Anybody can lock it, but only the person who has a key can unlock it, right? So that is the public private key. Private key is like having the key. Who can open the lock? The person who holds the key. Public key can be used by anybody to lock it. Okay. So if I want to securely communicate a message between you, let's say I want to securely communicate a message between you, you can have a public private key that you have generated. Okay. So you can keep your private key, which you only know. Then you give me the public key. So public key has nothing to do with that. So that doesn't compromise your security. You give me the public key, it is like you give me your lock. And in an unlock condition, you give me the lock. I put the packet in the suitcase, I push it. The only thing I can do is block it. When I send it, nobody else can open it because the private key is only with you. So it is like a push lock. I want to securely transmit an object to you. You have a push lock, the key is with you, that is private key. And the lock is the public key. Understand that way. You give me the public key, I will put the content in the box, lock it, then I will put it in the transit. Nobody can open it unless they tamper the lock. If they tamper the lock, you know that it is compromised. You won't consume the data, right? So you can use public private key for authentication, for mainly confidentiality, sharing the information in a secret manner. Okay, so and that can also be used for authentication. Authentication, how do you use public private key for authentication? For example, I want to know who you are, right? So for example, let's say you are running a cab company. In the cab company, you wanted to take you want to hire drivers who are really trained. They have license, right? How do you recruit a driver? What documents you verify? Okay, so she learned driving. She got a license, but you can also carry her license, right? But how is that problem solved? That driver license has a photo, right? That if she got the license, you cannot use that license because That driver's license tells two things. One is her photo is there. So by seeing the driver's license and the face, I can verify. That is a public key. Okay. And I rely on that license. Why I'm relying on that license? Because that is not issued by anybody else. It is issued by the government, right? Government and undergoes a certain systematic procedure to give you the license. So I believe the government. I trust the government. In cryptographic communication or security, there is at least one source that you should trust, and depending on that, you create the whole security framework. Okay, so I trust here the government. Any driving license issued by the government, I trust the government. So the document is original, it's not spoofed by somebody else, and I can verify this person by seeing the photo. Okay, so how do I use public private key for authentication? So I will generate a private key which represents me. Okay, and public key is kind of a lock. So I create a certificate. That certificate is given by some person who is trusted by the internet. And what is that entity? Have you heard of certification authority, like VeriSign and people like that? If you go to the browser, any website you access with HTTPS, there will be a lock symbol. If you click the lock symbol, what do you see? There will be a certificate that is shown that tells you the identity of that this website is authenticated website. How is that? Because that certification authority is centrally trusted by all the internet community, and that certification authority assess that particular website, then they give a certificate, and that public key inside the certificate tells that this belongs to that website. So if you want to send something secret to that website or an entity, you use the public key in the certificate and lock it, send it to that entity, they will open it with the private key. Okay, so you can also verify the authenticity of that using that public private key system. Okay, so we have seen that authorization and authentication is essential security mechanism. There is one place where you can extend this authorization authentication mechanism is packet filter. Okay, what it means is basically any packet that goes through the network, you just let it go, but you put a screen. Okay, it is something like a firewall. It's like a minimal firewall. Any packet that goes, I will verify whether this from the packet, from the header information, I know where that is destined. Is that user eligible to receive this packet? I can verify. There is something called access control list and things like that. I can do that filtering, and then I can eliminate this packet is not needed because that person is not authorized now. Okay, once somebody is authenticated and authorized to do some services, how do I enforce that he will be receiving only that services? If some packet which is related to a service that this guy is not authorized, I can use a packet filter to block it. Okay, so this is a mechanism that enforces or extends the authorization and authentication mechanisms in the security model. One example is Cisco uses access control list, which will tell you how to control the traffic in the interfaces of the resources based on whether that destination is authorized to receive the packet, things like that. Okay. Firewall, you might have heard. Firewall protects everybody because any traffic that goes out, it has to go through the firewall. Any traffic that comes in, it has to come through the firewall. So that there you put the policy. If it is a student, you want to block any packet that goes to Facebook, you can do that in the firewall. It is basically, you can think of a enhanced version of the packet filter. Basically, packet filter is one of the mechanism used in firewall. Okay, so apart from the firewall, there are additional security mechanisms in place in the network, which is IDS, which is called as intrusion detection system. Okay, as I mentioned earlier, there is an ARP spoofing that can happen. There are many other places where people can intrude into the system and then compromise the system. So IDS is a system which will try to analyze the system network events or network traffic that is happening, traffic that is going in. For example, if I do an SQL injection, if I do a SQL injection, if I see, if I can, if it is not an HTTPS traffic, I can see what is the payload. I can see that this is something not a user name, and then I can even detect that this is a malicious thing that is happening, right? So this is called as WAF filter, web application filter, things like that. So I can monitor the traffic and identify any anomalies that can happen or any malicious thing that is happening in the system. I can immediately kind of locate the problem in the network. That is intrusion detection system, which is another kind of security mechanism used by the network administrators. The next comes little advanced, which is um, IPS. IPS stands for Intrusion Prevention System. What it does is it just does not stop in detecting, it will also come out with its own way of preventing. How do you prevent? Let's say I am seeing that this computer is generating spurious traffic, which is not good, which is not a normal one. So, what do? You always have a firewall. In the firewall, what you do a packet filter. When I say that from this computer, I'm detecting something malicious is happening. What I can do, I can go write my own ACL. That is, I can write my own packet filtering. Say that whatever comes this port, don't accept it. So you are trying to prevent that intrusion as well. You go beyond the detection. You are also trying to prevent it with the help of dynamically adding some filtering policies in the firewall. Okay, so it is like entire thing gets an automated system now. Okay. So the first one stops with just identifying the problem. Second one tries to mitigate the problem by taking some packet filtering mechanisms. And finally, which is typically overlooked in network security, the thing is physical security. Whichever the enterprise is maintaining, you need to enforce that it is physically secure. Any access rack or distribution rack should be locked, and then any place where you have a very critical infrastructure like a data center should be deployed with physical security personnel and things like that. So this is also one part of security mechanism, not really technical though, but you should not overlook that as well. Okay, because really people can go rewire it if they want to attack the machine. Okay, first what we saw, some typical mechanisms and systems in place to handle this network security, but it is not an ad hoc fashion. It's like I cannot throw a packet filter here, I cannot put a firewall there, I cannot put an IDS there. There is a principled approach to take that. What is that principal approach? That's what is shown in here. So this is called as in-depth principle. What it tells you is, if you want to protect from some attack A, okay, and you have a mitigation technique to counter that attack, to protect from attack, from that attack, you have a counter security mechanism. What this principle tells you is, don't rely on one security mechanism to protect from the attack. You create multiple security mechanisms to protect from the attack, because every security protection system has a false probability, or you can bypass that. So if you have a multiple security mechanisms to protect from one attack, if one misses, another one may able to protect you. So that's what is called as defense in depth. Depth means you have multiple layers. One layer you do one security protection, another layer you do another security protection, and something like that. Did you notice that in one of this thing? Packet filter is a mechanism. Firewall is also doing that. Packet filter can happen in the router. Firewall is another device that can come after the router. So you are doing packet filtering here, and then firewall also does the packet filtering. You have an in-depth defense here. If router misses in its packet filter, maybe firewall can catch it up. So that's the principle. So what it says is, you in a network you go horizontally and vertically. That's what it says. So this in-depth means horizontal. You have multiple protection strategies to protect from each attack. And the second thing that it says is belts and suspenders approach. What it says is, don't keep all your protection strategy of the network in one place. It can be separated. It can be in different parts of the network. So that's what the second technique tells. so that it is not a single point of failure. You can have multiple. It is kind of horizontally put in your multiple places. For example, you can have a firewall here and you can have a firewall there. If this is down, this one will kick in and then do it. If you have one switch here and another switch here, you can basically, if this switch is down, ensure that the traffic is routed to the other switch. You add redundancy here. So you also ensure the mechanism is redundant, and there are multiple mechanisms in place. This is a simple security design principle. Okay. The other design principle is a modular. Basically, you have multiple layers. You don't have one monolithic security principle. You design your security principle as multiple modules for maybe for each one for different purposes. That's a modular design. But the whole takeaway in this slide is you should have a hierarchy of redundant schemes, and there are redundant protection measures put in the system, so that when something goes wrong, the other one will work. When the service is down, the other redundant service can kick in. Okay. So now we are in a position, we understood the basics of the networks, some potential attack surfaces, and how the security design principle we should take care. Now we'll come to a very simple example of how to design our network. Okay. So this is typically called as a campus network, because campus typically handles the thousands of end user devices. You can map it to an enterprise network where you have a large organization with multiple people working. This will work. So the goal of this campus network design is I need to have a network inside my campus which should have all these three goals satisfied. What do you mean by availability? If I connect my computer to an access point or a switch, and if the switch is down, I'm completely isolated from the network, right? I cannot have internet access. So in order to avoid that, what I can do, I can have a parallel switch connected. Okay. So basically what it says is, okay, let me a typical computer network, campus network design looks something like this. It is a three-tier architecture. Okay. The first layer is access layer. This is where end devices are connected. Okay. And let's say this is a building, and finally the building will have one switch, which is the distribution switch, and all the access switch are connected to the distribution switch. And your campus will have multiple buildings. This is building 1, this is building 2, and this is building 3, and so on and so forth. Everyone will have some access switches in each floor. Finally, end of the day, before coming out of the building, they go to a distribution switch. Okay. And all these distribution switch go to the data center, where your ISP, the internet to the campus, is provided. In the data center, there will be a core switch, and every distribution switch is connected to the core switch. It is something like a network topology. In my campus, the internet comes to my data center. I have a root node, which is the core switch, and then I have, let's say, 3 buildings. This is building 1, building 2, building 3, and every building has a distribution switch. And then every from the distribution, you go to every floor, they will have an access switch, and then all the end devices are connected to the access switch. The end devices are connected to the access switch. So there are 3 tiers here. One is access layer. This distribution switch layer is called as distribution layer, and this is a core layer. So almost many enterprise networks or campus networks follow this 3-tier architecture because they satisfy all these goals of availability, performance, and expandability. Okay, but the availability is still not ensured here. Why? For example, if this distribution switch is down, anybody in this building will be isolated. Nobody can able to connect to the internet. Okay, so in order to protect from that kind of single point failure, what you should do, because this distribution switch is the only switch that is leaving the building, that connects the entire building devices to the internet. So in order to avoid that, what you should do, whenever there is a single point of failure, what you do, you put a redundant device, right? If this device is down, the other device should kick in, right? So what typically people will do is, um, if there is an access switch, this is the building, okay, the access switch, the distribution switch will be kept 2. This is the distribution switch 1, this is the distribution switch 2, and each access switch is connected to 2 distribution switches which perform the same in an active mode. Okay, this is a fiber that runs on one side of the building, this is a fiber that runs on another side of the building, which is called as edge, okay, I think path, edge and node diversity. Sorry for the typo. So what you do is, this access rack is not connected to one distribution switch like you saw here, rather I connected to the 2 distribution switch. Okay, so and these 2 distributions which are placed in separate parts of the building, and they are connected with not one fiber cable, 2 different fiber cable that goes in different path. Why it is different path? If this side of the cable is cut due to some reason, maybe somebody electrician has cut it, you can have the other cable that is running, that will work. And core switch C1, now you have 2 core switches. This distribution is connected to core switch 1, and this distribution is connected to the core switch 2. This is in a different building, and in the campus the backbone fiber goes in one path and another fiber goes in another path in the building. It is like a loop, like from building a cable goes around one corner of the campus and go to the core switch 1. The same distribution, another fiber goes to another region of the campus, goes to the core 2. Likewise, D1 is connected and D2 is connected. Okay, and then both are connected to the router and then goes to ISP. So every access switch in the building is now having path redundancy, edge redundancy, and path diversity, edge diversity, and node diversity. What do you mean by that? If any link is cut, all the network can be routed to the other path, right? If any device is down, node is down, the other device will act as a standby and the traffic will be routed there. Okay, so this is called as availability. So this is how a typical network designer will design the network so that it has all sorts of redundancies in place. Okay, now I want to achieve a high performance, I need a small broadcast domain. This is something to do with the layer 2 which we discussed in the beginning of the talk. What do you mean by that? What is a broadcast domain? You have a shared medium. In that shared medium, you need to reduce the number of devices in that so that the collision is less. More devices, more collision; less devices, less collision. Right. So in a bus topology, you have one wire, multiple computers are connected, they collide with each other. If you connect one device to one port, you reduce your broadcast domain. Okay, and small bandwidth domain is basically, you also reduce your bandwidth domain within the system. What it means is, um, this is something you have to do again with the star topology. So host 1, host 2, 3, host 4. So this is the switch. Okay, so this is your containing your bandwidth in a star topology. In a broadcast topology, so this is your containing your bandwidth. Broadcast domain is, now when H1 wants to know the MAC address of H4, it will flood the packet using an ARP protocol. Now everybody will receive, right? So what is a broadcast domain? The broadcast domain is the entire set of switches. Can I control this broadcast domain to only 2 switches? I don't want my broadcast domain to contain all the 4 hosts, because everyone starts flooding. Then my switch will handle a lot of flooding traffic. But I want to reduce this broadcast domain to a smaller one. Can I do that? For example, I want to split H1, H2 to be in one broadcast domain, and H3, H4 into another broadcast domain. If I want to do that, what I should do? Ideally, as a network designer, you have to put this in one switch, and you put another switch H3 and H4. So this will be in one broadcast domain, and this will be in another broadcast domain. But this is not a economical solution, because you cannot just split the devices just because you want to put them into different broadcast domains, right? So I want to reduce the number of switches, yet to put them in the different broadcast domain. What I can do? You have one computer, you have one operating system, but you want to run, let's say that is a Windows computer. Now you want to run an Ubuntu operating system. What do you do typically? You buy another computer, you put Ubuntu, or what else you do? You want to test the Ubuntu application. What do you do? You have a laptop with Windows. You want to run an Ubuntu application. What do you do? Yeah, it's a virtualization, right? You have a virtualization software. You run it. You run different operating system inside your computer. Like in the same way, switches also support virtualization. You call it as virtual LAN, VLAN setup. Okay, so you can assign this port of H1, H2 in VLAN 2, and you can assign these 2 ports in VLAN 3. So what it creates is, it virtualizes a network. Logically, you can think of that as 2 things. Though it has one switch, 2 hosts are connected to VLAN 1, 2 hosts are connected to VLAN 2. Only these hosts can talk to each other, and only H3, H4 can talk to each other. If somebody is flooding, that flooding is controlled within that broadcast domain, right? So like using the VLAN concept, you can reduce the broadcast domains in an effective manner, so that any flooding that happens is contained within some network. You can isolate the network. Okay, so for example, I have a lot of cameras in this campus. I have a lot of computers. If all the cameras and computers are connected to the same switch, when one person does the flooding, everyone will receive it. Rather, I don't want my camera to be part of this flooding. I can put all the cameras in one VLAN, and I can put all the data ports in another VLAN, so that they are separated and the flooding and broadcast domains are contained. Okay, so this is one way of containing the flooding, because flooding is the main reason of attacking, denial of service attack. From an attacker's point of view, you contain it, you contain any compromises contained within that broadcast domain. Okay, the third important metric is expandability. Whatever design I am designing in my campus, I should not change when a new building pops up. I should not change drastically any connectivity infrastructure when new IO points start coming up in the campus. So since I use a tree topology, if a new building comes, I put 2 more distribution switches connected to the core switch. So my design is still intact. It is scalable, which means it is expandable, and it is also easily maintainable, because all the traffic as goes down to the internet, it gets aggregated. So any issue that happens in the network, I can easily scan layer by layer and identify the problem. So maintainability is easy, and scalability is also easy. Okay, so you can think of this as a network administrator's point of view, but also as a network security point of view, because all these things helps you to protect from some potential attacks in the later stages. So this is what I have said about the 3-tier architecture. Access layer, which connects to the end devices, and all the access switches connect to distribution switches in the building, which is the distribution layer. And finally, all the distribution switches in the building goes to the core layer. That is where the internet firewall, everything is sitting. That is the IT center or the data center of the campus network. Data center consists of other servers as well, but this is just the server room of the system. Okay. The other thing that decides the whole topology of that is um, uh, you are doing some sort of redundancy in the whole system, right? When there is an access switch there that goes to the distribution switch, that goes to the core switch. So you have a core switch, and this is connected to another core switch. You have a distribution switch. You have another distribution switch, and there is an access switch, and there is a link. So this is how I introduce link. There is a fundamental problem in this design. What is that? When I send an ARP packet, right? What is the purpose of an ARP packet? I want to identify the MAC address of the destination. And what is the job of the switch when it sees an ARP packet? It floods to all the interfaces. That is, when it receives the packet here, it floods to all the interfaces that it sees. When this switch receives, it floods to all places it receives. And do you see that there are some cycle or loop inside the graph? When everybody receives and send it to the every outgoing port, your flooding packet keeps on circling inside the network. What is the difference between a graph and a tree? Graph has a cycle. Okay, what happens when you have a cycle? Let's say in an ARP protocol, what the ARP protocol says is whenever you receive a broadcast packet, except the incoming port, all other ports you have, you transmit that packet. So a packet comes here, so it will forward the packet to the outgoing port. Then that packet travels here, comes here, it will be transmitted. It comes here, it will be transmitted. Again, it will be looped back. So whenever you have a loop, flooding keeps flooding the packets itself inside the network. So over the time, your network will be seeing all ARP packets being flooded. How do you stop it? What is the fundamental flaw here? There is a loop. You have to break the loop. In order to convert a graph into a tree, what is the tree that you do? Spanning tree. Spanning tree is a tree structure which spans entire vertices of the graph, but there will not be any cycle or loop in the system. So fundamentally, all these things will have a loop. So there is a protocol that ensures that this looping will not happen. So it constructs a tree on top of this graph of switches, so that any flooding happens, it will not be looped all over. So that protocol is called as spanning tree protocol. It is a functional aspect. It is also a security aspect, because if loop is there, then you will again the flooding will keep circulating inside it, choking the whole network. And what is the attack surface here? The spanning tree protocol exchange some information to construct the tree. If this information is not delivered in a timely manner, the spanning tree will not be constructed. So attackers try to reduce this propagation of this this control packet, so that the spanning tree is not formed and creates a lot of loop in the system. So that is another attack surface. Okay, so switch manufacturers will have to have a way to deal with that. Okay, so this already we discussed. So you need to do a VLANing, virtualized LAN, for reducing the broadcast domain. And in order to do that, there are a lot of vulnerabilities in the VLAN. I wanted to do VLAN to reduce my broadcast domain, but introducing VLAN introduces its own security. One thing is called as a spoofing attack. What is a spoofing attack? You have a switch which has two devices, H1, H2, which is running on VLAN 1, and there is H3, H4, which is running on VLAN 4. There is another switch which has H5, H6, which runs on VLAN 1, and there is another, let's say another one switch, let's say H7, which runs on VLAN 2. So what do you mean by that? H1, H2 is running on VLAN 1, H3, H4 is running on virtual LAN 2, and H4, H5, H6 is running on VLAN 1 and H7 is running on VLAN 2. So what it essentially means is H1, H2 and H5, H6 are on VLAN 1 and H3, H4 and H7 is running on VLAN 2. So how do you send the traffic of hosts sitting in one switch on one VLAN to the other switch? So by design, switches have another port called as trunking port. So in the trunking port, uh, packets from different VLANs will be routed, and there is a protocol that carries this traffic and then finally splits it across to the different VLAN. So one particular protocol is called as 822.1q, if I'm not wrong. This is called as a trunking protocol. If a packet, if H1 wants to communicate to H6, H5, is that possible or not? Ideally, it is possible because logically you are putting them on same VLAN, which means physically they are separate, logically they are in one LAN, one network. H1 should able to transfer data to H5 because they are on the same LAN. So this trunking port is used by the switch. So whatever H1 is delivering, this trunking port puts the VLAN ID and then sends the frame, and the packet is delivered here, and in here the VLAN tagging is removed and the packet is delivered to the H5. So that is a protocol which is used by switches to carry the traffic over multiple switches over the trunk port. So trunk port is something like a highway. One person want to transfer the traffic, you tag that frame with an VLAN ID, put it into the trunk port. The trunk port carries it. On the receiving end, you see the trunk VLAN ID and send it to that particular guy. But attacker, what they do is they spoof it. What they do is they pretend as if they are they take control of this trunking thing. They behave as if as a switch, and they receive all the VLAN traffic that goes in. So what is the vulnerability in this trunking port? This this link carries traffic from all VLANs. I can read traffic from VLAN 2. I can read traffic from VLAN 3, 4, anything. If an attacker pretends to be a switch that carries the trunk traffic, the switch will automatically send every traffic to that attacker, which means an attacker can eavesdrop all the traffic from each VLAN. The fundamental concept of VLAN is I should not hear the traffic from one VLAN to the other VLAN. If an attacker pretends like a legitimate switch and creates a trunk link, switch will transfer all the VLAN traffic to that attacker. So you can eavesdrop all the traffic independent of the VLAN. Okay, so that is one possible attack that can happen in VLAN. The other one is double tagging, where I can even send a traffic which to other VLAN whom I'm not authorized to do that, where I can use a double tagging setup. So which is also possible by means of native VLAN. Let's not go into that thing. Basically, what happens is if I have a VLAN, I belong to VLAN A. What I'll do is I will put VLAN A, and then inside I will put another tag for VLAN B. As it goes through the switch, my first tag is removed, and switch will think that this traffic is for VLAN B and the traffic packet is sent to the VLAN. I do the double tagging in my VLAN setting. So how do you attack? How do you mitigate from VLAN trunking? The whole principal approach is be very paranoid. Be very cautious. You should not allow any switch to behave like a to connect to the trunking port. You should not enable the trunking port. Uh, you should be very careful because trunking port is used to connect between two switches to carry the all VLAN traffic. As a network administrator, you should be very cautious in enabling a trunking port because you should not leave that open for any attacker or any other host devices to use it. So that is the first thing. The other thing is if any port is unused in the system, in the switch, there is some option in the underlying in the switch hardware that tells you to temporarily take this port down. What it means is nobody can just connect to the port and get it activated. So you have to administratively enable the port. So whichever port is not used, don't leave it open. You administratively take the port down so that an attacker just goes and plugs it in. That port is not enabled. Okay, so these are the security measures that you can do to protect from all this VLAN spoofing and double tagging attacks. Okay. So now these are the things that can happen in layer 2 apart from ARP spoofing. Now what happens is, let's say you have two different campuses. Let's say you have a main campus and you have another campus in somewhere in different parts of the country. Now these two campuses need to be connected to each other. You cannot, because this is not in within a LAN which is across LAN. There is a internet that is connecting these two campuses. Internet is a public network. What it means, if you are not using HTTPS traffic, if you do HTTP, any router which is along the way can read all of your packets. Let's say these two campuses want to send some confidential information. What you do, whatever is inside the network you can protect. You are the network administrator for it. Whatever you have the other network administrator in the other campus, they can protect the network within that. But now the traffic is moving to the public internet. They are exchanged over the public internet. How do you protect it? Internet you cannot control. It is run by public organizations and many commercial people. They will eavesdrop it if you send any information, right? How do you protect it? What is the mechanism to protect it? Have you heard of IPsec? IP security protocol, and that is the one that is going to help you. Okay, but there may be if you have seen the IP packet, there is a field called checksum. What is the purpose of checksum? Checksum will ensure that if the packet is tampered, right? If the packet is modified or tampered, your checksum is a way to verify whether the packet is modified or not. Okay, but here, when a packet goes to it, an eavesdropper can eavesdrop the content. They can also modify the content. Okay, I am sending content A to you, but a router will change the content to B. You will receive that content as B, as if it is delivered from me. Okay, but checksum will not help to detect it. Why? Then what is the purpose of checksum? Purpose of checksum is, in case a packet in transit is damaged because of some malfunctions, checksum can detect. But if a cautious attacker wants to modify, why would he modify only the content? The attacker will modify the content, create a checksum for the content and place it. Now the packet is not modified, right? It is, for example, you have an Amazon parcel, okay? And what is a checksum? Checksum is the list of items in that box. If in case something is lost in transit, checksum is, you take the list in the box, you say that okay, item A is there, item B is there, item C is not there. Then you say that okay, item C is missing here. You identify, that is checksum. But checksum won't help here, because if I am an attacker, I open the box, I replace the item, I replace that bill, that list of items. So I manipulate both the checksum and payload. So checksum will not help here in this attack surface, right? So now what is the way to do it? What is it? Can you come up with a technique to avoid it? This is where cryptography comes in. Cryptography is basically someone is tampering it, because anybody is allowed to tamper it. IPsec should not allow it. So you use your public private key system, and if somebody has tampered, right, you can easily identify. So that is the purpose of your IP security. What it means is, both the parties who want to transfer, campus 1, campus 2 gateway routers, they will have a cryptographically secure communication. Anything that goes will be with the public key of that sender, and receiver will see the public key and ensures that this public key belongs to that particular sender, because that is certified by the certification authority, and use the private key to decode it. If somebody tampers it, they cannot tamper the public key. You have to change the public key. Then you know that something is tampered, you discard it. Okay. For example, you want to send a packet with your sign on it. Somebody can replace. Nobody can replace both of the things. We are assuming that the sign cannot be reproduced. If somebody wants to replace that letter, they cannot put your sign on it. Right? It is the same way. You create a cryptographic system where the signatures are stamped. Anybody who tampers in the middle, you will identify, you ignore that packet. Okay, so that's the thing. So that is the world of IPsec, which will help you to connect two different campuses, which runs over the public internet, which is exposed to all types of attacks. Right. So what is IPsec in a very simple term? You use some cryptographic techniques to encrypt and decrypt packets. In other words, you create a logical tunnel, and in this logical tunnel, you send the packet from end to end trusted nodes over untrusted network of devices. Okay. And this is IPsec. In other words, you can think of that as a VPN. How many of you have heard of VPN? Virtual private network, right? So when you are working in a company, you are going on an on-site, you are going to a customer site, you connect to your institute company network through VPN. How is that possible? Through IPsec. So IPsec is not just to connect one network to another network. It can also connect a host to a network. You are in an IT company, you are in a network. Everything is protected by that administrator. When you go out, you want to connect a resource in your network through the internet. You establish a VPN connection. That is also host to network. Or two hosts want to connect to each other over IPsec. That's also possible. Okay, and these are some preliminary questions. How do you ensure that the parties are who they are before establishing a secure communication? For a secure communication to happen, you should trust the sender and receiver. How do you trust them? In the driving license example, there is a trust. In always in a security, there should be someone you should trust. In here, this is the in a driving license concept, government is the one that you trust. Whatever the government issues, you assume that it is trustworthy. And in internet, there is a entity called a certificate authority that verifies all your identities and gives you a certificate, and it puts the signature of the certification authority to ensure that the document is issued by them, and the public key of the owner is also there to ensure that this owner is that particular person. Okay, so that is needed because you need to first trust the endpoints, then only you can establish a secure communication, right? Now the key question is, are we using cryptographic communication only in layer 3 like IPsec? No, not at all. Every layer you are using cryptographic security. Are we using something in the layer 2? Yes. It's called MACsec. Okay. So MACsec is used in a very high profile or high critical infrastructure. People should not eavesdrop in the link. One switch is there, devices are connected. People should not just hear the what is happening transmitted over the wire. So even the switches will do some sort of cryptographic exchange of keys. All the data in the links are also encrypted, and the protocol that does this is MACsec. Okay, so the underlying cryptographic technique is same. The protocols and things differ in different layers, so the naming differs. Okay, so that is MACsec, and it also happens in the application layer, which is the TLS security. Whenever you see HTTPS instead of HTTP, HTTP stands for secure HTTP. It uses transport layer security. What it does is the applications talk to each other in a secure manner. The network can also be the enterprise network can be compromised. Your public internet can be compromised, but the end-to-end application will have their own secure channel. They have that trusted communication. That's how you talk to Google. You rely that Google is authentic because you see that certificate. Everything is kind of what is it, authorized by verified by the certification authority. So the cryptographic layer that you use in the application layer is the TLS security. Okay. These are the use cases of the TLS. You are a computer, you are a browser, you want to access a web server like a Google, you can use this TLS security. Or you have an application, you have a service in the cloud, you want to securely talk to that cloud, you can use this. Device to device, I have a sensor node and I have an application processor, they want to talk to each other secure manner, you can use this TLS in the application layer. And now comes to the key part of it, whatever we are saying, right? Who is doing this? Who issues the certificate? How do you ensure that this person is the person who is the really the person who wants to communicate, who certifies it. Everything comes under the standard which is called as X.509 internet application. Okay, so I think PKI stands for public key infrastructure. This is a framework that um, gives certificates, maintains certificates, and then gives a framework for everybody uh, to uh, to verify their identities and then get into the negotiation of secure channel communications. Okay. Uh, so here the key component is certificate. What is a certificate? But certificate is analogous to the driving license or some ID card. Uh, why is a driving license trusted? Trusted for two reasons. The photo and the owner of the license is easily verifiable, so that you cannot get a driver's license and somebody cannot use it because your face is there. I can verify. Okay, I can believe the driving license in that sense. You submit the driving license to me, I know if you are the person who really got the license. So certificate should also really tell that this is the sender who wants to establish a communication. I can verify. The other thing is, how do you certify that license? Somebody can generate that license, create a photocopy of it, or duplicate it, because this is issued by a government agency. I believe that. So I believe the certification authority in this aspect, right? So my certificate is believed here because of these two reasons. So the public key is which is written on that certificate tells that this is the owner whose public key is this, because otherwise I cannot trust that sender. And how do I know that the certificate is authentic? That is signed by, digitally signed by that certification issuing authority. It's like a government. Okay. And what are the key components of this whole infrastructure? There should be one entity who issues the certificate, and if the every certificate has a lease time, you have to reissue the certificate. Somebody behaves badly, I have to revoke the certificate. All these things are done by the certification authority, is an entity. And what are the other components? You will not directly have the driving license like that, right? You have to get the driver's license. What you do, you go, you give your driver's test, you do some exam. There is a process of registration. After you clear everything, finally you will be issued with a driver's license. Likewise here, who is issuing the certificate? Certification authority issues, maintains, and all those things, but who procures, gets the certificate? There is a registration process that is done by registration authority. So registration authority, what they do is they will verify uh, who you are. How can I? What is the evidence that proves that who you are? Maybe it could be an email, right? So what this registration authority will do is, okay, I will send you a OTP to your email. You tell me what it is. Then I can verify that this email belongs to you, and in that way I can verify that this email is for you. Or I can do some sort of interview, or I can do some sort of other ways of authentication that we discussed in the first part of the slide. This is the process done by the registration authority. After everything is verified, I give a valid certificate to a particular person who will use the certificate for establishing a secure communication. And this is the most important. What is the whole purpose? I first need to procure a certificate to ensure to show the world that I am trustworthy. Then people will try to establish a communication using my public. So I am the certificate holder who possesses this a public key. And when I hold a certificate, somebody is there to use the certificate, that is the user, okay, who wants to transact with me in terms of accessing my web service or any other thing. And finally, you need to have a database of all the certificates. CRL stands for certificate revocation list. If by any chance any certificates is revoked for some reason, this database maintains that. So this is the database. People go and verify whether the certificate is valid or not, or if the certificate is revoked, you go in a single place and verify that. So a public key infrastructure is the place that issues all the certificates, maintains it, and this is used by anybody who want to establish a secure communication. It is used to verify the trustworthiness of the parties that want to establish a secure communication. Okay, this is used in various layers: application layer, IP layer, MAC layer. As long as you have uh, people who want to establish a trustworthy communication, you need to rely on this kind of support service framework to establish or verify the identity of the users. Okay. Coming to the last part, which I want to repeat. Earlier we said there are broadcasting is good, is required as a functional requirement for the network, but it is a, security vulnerability, because whenever there is a broadcast, there is a possibility of spoofing it. So broadcasting is a necessary evil. So ARP and DSCP uses this broadcasting, but on the other hand, attackers use poison this ARP protocol by poisoning it. They behave as if they are the target device. They send their MAC address. In DSCP spoofing, instead of a trusted DSCP server giving the IP address, attacker releases the IP address and then takes control of the entire internet access. So now comes to the mitigation part. How do I protect from ARP attacks? The solutions are very simple. First thing is, you always keep monitoring your switch for ARP inspection. If there is any spurious activity that is coming in, when multiple times one device is replying with an ARP packet, and that is not part of your network, because a network administrator knows like all the trustworthy hosts. So what you can do is, when one device is sending the MAC address of some other device, right? So in a star topology, each host is connected to one port. Ideally, if it is a trustworthy host, only one MAC address should go. If it is an attacker, he's spoofing the packet, is sending multiple MAC addresses. So this is one indication for the switch seeing that somebody is trying to spoof. So what you can do is, you can enable a port security, saying that only one MAC address should be coming from one port. If multiple MAC addresses coming, possibly that host is behaving as an attacker and spoofing the packets. So you can stop doing that. And if say that ARP's poisoning is done and every traffic is eavesdropped, what you can do is, you can rely on higher layer attacks, like higher layer security mechanisms like application layer security. What is the use of application layer security? Even if an attacker poisons, does the spoofing and compromises it, and overhears all the traffic in the man in the middle attack, the packet cannot be decrypted, because the higher level is secured traffic. The HTTP traffic, it can see, it can overhear, but it cannot understand what it is. So higher layer security mechanism can help here. So likewise, you can do all these kinds of mitigation, but not all security is foolproof. There are some probability of missing it. So that's the reason I said earlier, in a principled approach, you have to do multiple security mechanisms. When one misses, other may try to catch. How do you mitigate DHCP attack? It is very simple, because if DHCP server is trustworthy, who says that the DHCP server is trustworthy? Who deploys it? The network administrator inside the enterprise network will deploy it. So they know what is this DHCP server. They can put a certificate and ensure the trustworthiness. If anybody else is behaving and issuing the DHCP address, you can easily spot them, right? Because they are not trustworthy, which means if you see in a switch anywhere any host is replying for the DHCP, you can block that port, right? Because you know the DHCP server comes only from the trustworthy machine. You can enable only DHCP packets to pass through only that port. Everybody else should behave only as a host, not as a DHCP server. Therefore, you can protect untrusted DHCP servers from attacking the network, which is a process called as DHCP snooping. This is something like a firewall. You allow only DHCP packets going to only DHCP server. Every other port should not be allowed to transmit DHCP server packets, something like a packet filtering. Okay. So the mitigation is very simple. Once you understand the attack surface, the mitigation gets very simple. Okay. So all these security principles and the way of mitigations are pulled mainly from these two books. If you want to refer to more details, you can refer to this book. I hope you got an idea of what is a network thing. Network is not just connecting two computers by wire. There are a lot of protocols in place. There are a lot of attack surfaces. You have to have a principled approach, and there are different mechanisms to attack different problem. And there are also some general a kind of sanity check that you have to do in while you're deploying a network infrastructure. Okay. Any questions? So hope you got a feel about different jargons used here, and a principled way of enforcing the infrastructure is secure. End of the day, your cryptographic technique is used as a secure communication channel. If A and B want to talk to each other over an untrusted channel, use your cryptographic technique. That's a simple principle. But in a network, it is different. There are different types of attack. You have to handle it in a different manner, understanding the attack surface of different layers. Okay. So with that, thank you very much for listening patiently for the entire session.